Hello everyone and welcome to Honors Pre-Calc. Today we're going to be talking about 6.5 basic trigonometric identities. So we're going to start with the basics of SOHCAHTOA. So what you already should know is that sine is equivalent to opposite over hypotenuse, cosine is equivalent to adjacent over hypotenuse, and tangent is equivalent to opposite over adjacent. So now we're going to look at their opposites, which for sine is the cosecant, which is hypotenuse over opposite. For cosine is the secant, which is equivalent to hypotenuse over adjacent. And for tangent is the cotangent, which is equivalent to adjacent over opposite. So now let's get into our first identity, which is the quotient identity. So looking at this, we're going to say that tan x is equivalent to sine x over cosine x. Now we know that the opposite of tangent is the cotangent, so those numbers are just going to be flipped. So as tangent is the opposite over adjacent, cotangent is adjacent over opposite. So for cotangent x, you're going to have cosine x divided by sine x. So now let's apply this to an actual triangle. So let's say we have a 3, 4, 5 triangle, and we're going to try to find all of them for theta. So sine of theta is equivalent to 4/5, cosine is equivalent to 3/5, and tangent is equivalent to 4/3. So since we know that sine over cosine is equivalent to tangent, 4/5 divided by 3/5 should give us 4/3. Now knowing that the cotangent is opposite of tangent, we should know that 3/5 divided by 4/5 should give us 3/4. So now we're going to plug this into our calculator and see if that's correct. So we'll first go to math, over to number, and down to letter D to get the fraction button. And then you just plug in the numbers as you go. So checking, we see that 4/5 divided by 3/5 gives us, in fact, 4/3. And now we're going to check for the cotangent. And we do the same thing, math over to number and down to letter D. And 3/5 divided by 4/5 gives us 3/4. So now let's go into our next identity, which is the reciprocal identity. So these are all the identities. Sine x is equivalent to 1 over cosecant x. Cosine x is equivalent to 1 over the secant x. Tan x is equivalent to 1 over the cotangent x. Cosecant x is equivalent to 1 over the sine x. Secant x is equivalent to 1 over cosine x. And cotangent x is equivalent to 1 over tan x. So pretty much we can sum up that they all are flipped or opposites of each other. So sine x is equal to 1. 0.28. So let's plug this in to try to find the cosecant, which is 1 over sine x. So we do 1 over 0.28, and you get 3.57. Now we're just going to plug that into the calc to just double check everything. All right, now pause the video and try this next one on your own and come back to check your answer. So now we're going to try for cosine, which we'll say is 0.96. So let's try to find the secant of x now. So that's 1 over cosine x, or 1 over 0.96, which is equivalent to 1.04. And again, we're just going to plug that into the calculator and see what it comes out to and make sure we got everything correct. So our next identity is the Pythagorean identity. And these are all of the identities for them. All right, so now we're going to simplify tan squared x times cosine squared x plus cosine squared x, or t. So tan squared, we know, can divide into sine squared t divided by cosine squared t times cosine squared t plus cosine squared t. So the cosines all cancel, and sine squared t plus cosine squared t gives us 1. If we go back to our identities, we can check that and see that it in fact is equal to 1. So now we're going to make both sides equal by working with one side. So we're going to do the cosine squared minus the sine squared x side. So cosine squared x, looking at our identities, breaks down to 1 minus sine squared x, and then minus sine squared x. So you have 2 sine squared x. So 1 minus 2 sine squared x is your answer, and as we can see, it matches the other side. So now let's talk about the periodic identity. So sine x is equivalent to sine x plus or minus 2 pi, and cosine x is equivalent to cosine x plus or minus 2 pi. Tan x is equivalent to tan x plus or minus pi, and these are all for their domains. So you always want to try to get to 2 pi when you're breaking down these numbers. So sine 13 pi over 6 is equivalent to pi over 6 plus 12 pi over 6, and that 2 pi cancels, so you get sine pi over 6, which, looking at our unit circle, would equal 1/2. So let's just go to our unit circle and see that pi over 6 is equal to 1/2 for sine. So now try to solve this next one on your own and come back. All right, so cosine 7 pi over 3 breaks down to pi over 3 plus 6 pi over 3. Again, that 2 pi, it just cancels out. So we get cosine pi over 3, and that equals 1/2 looking at our unit circle. And we'll go to cosine pi over 3, which is 1/2. All right, so our next identity is the negative identity. So cosine negative x equals cosine x, sine negative x equals negative sine x, and tan x equals negative tan x. So now let's solve sine negative pi over 6. So looking at our identity, it will be sine pi over 6, or negative 1/2, which we saw in the previous example. So try this one on your own. So cosine negative pi over 6 equals positive cosine pi over 6 according to our identities, or radical 3 over 2. And we're just going to go to our unit circle to check that once again. All right, so our last identity is the pi identity. So cosine x equals cosine pi minus x, sine pi minus x, and negative tan pi minus x. So you always want to get to pi or 1 when you're doing this identity. So let's try sine 5 pi over 6. And use the denominator as your guide. So we'll do 6 pi over 6 minus 5 pi over 6, which will give us sine pi over 6, or 1/2. And we saw that on our previous example for our unit circle. Now let's try an example with cosine. So let's say we have cosine 3 pi over 4. Again, use that denominator as your guide. So 4 pi over 4 minus 3 pi over 4 gives us cosine pi over 4, which we get negative pi over 2, radical 2 over 2. So let's check that on the unit circle. And we see that it's actually positive radical 2 over 2. So why did I get the negative 2, radical 2 over 2? Well, we know that the cosine x is equivalent to the negative pi minus x. So all that means is that we have to do the opposite or negative for radical 2 over 2, which is just negative radical 2 over 2. And that goes for the tangent as well. But the sign is different. The sign is always going to be the positive. So thank you for watching, and I hope you did learn a lot about basic trig identities, and good luck this year.